everyone. This is Dr. Z. Welcome to join us for this series of episode where we're going to talk about technology, talk about computing skill, talk about the connection between computational thinking and education, especially for early childhood education. So for the next 6 episodes, I will have Dr. Lauren Margelo. So I have always have trouble pronouncing your last name.
Everyone does.
Forever. Yeah. So should I call you Dr. M? Do people have a nickname for you?
Dr. M's good.
Oh, Dr. M. Okay. So it's really my pleasure and my honor to have Dr. M here. And because she's been doing research related to computational thinking for a long time, and she's like one of the big person like in the field. So we will start with our conversation, like sharing our experience with you guys about why we think computational thinking, computing skills is so important in education right now, and how would that shape the future of education, and how can educators, professionals, maybe even parents, can prepare ourselves to better support children to be a digital citizen. You know, we have that new term coming up, digital citizen in our society. Okay, all right. So, Dr. M, why don't you just, briefly introduce yourself a little bit? Like, what happened in your life that brought you to this field?
So my background is in psychology. So I think about how humans think and behave. And part of that, my particular degree is in engineering psychology, how people think and behave while using technology.
Mm-hmm.
And so when I started graduate school, I didn't even know what computer science was. Like, I started working on this project with a computer scientist my first month of grad school.
Wait, didn't you go to Georgia Tech?
Yeah.
But you didn't know what computer science was?
No. I mean, I've never heard of it in like undergrad. I'd heard of it. I heard it was like really like math, and that was all I knew, and it was really hard, and that was literally the extent that I know of it.
Okay. But like, so what happened at that time that made you feel like, oh, it's so important, I want?
Well, so I met with this professor who was a computer scientist who was working with my advisor, who was an educational psychologist, basically.
Okay.
Studies how people solve problems. And they were working together, and they're like, have you ever programmed before? And I was like, I made like a MySpace page. And they're like, yeah, that doesn't really count.
So I born and raised in China, okay? So I remember the first time I ever touched on the keyboard of computer was in high school, and I was touching on this really old school Macintosh computer, and the programs my teacher was training us to do was basics. Do you remember that program? Did you have experience?
Basic, no.
Have you heard of Basic?
Yeah.
Have you heard of DOS?
Yeah.
Did you ever use DOS or Basic?
DOS when I was very young.
Like, when did that happen?
Probably like elementary to middle school.
Now, how did you learn DOS back then? Did somebody train you? Like, it was a teacher start teaching already?
I knew, like, you press these buttons to do this thing. Like, I didn't understand conceptually anything that was happening.
So back then in the U.S., when children in elementary or like in middle or high, they already have access to computer. Like, what did they use computer for? Because back then was no internet.
Yes, sort of. So the internet was started in '93.
Oh, you guys 93. Oh my God. I did not ever use internet until 2000. You guys were way ahead of us. So
yeah, I mean, it wasn't common. We didn't do like a lot of computers in elementary or anything, but like at home to play games and stuff.
So back then, computer was really for entertaining purposes. I think that's the same thing for us. Like when I was learning basics, the first thing I was trying to do is to find those programs published in a magazine or something and say, hey, if you type in those things, this picture will show up with this really boring music. But it was amazing to me. I was just like typing everything, like all of those English vocabulary that I could not understand what does that really mean. But it's like word to word, type everything, and then you show me a picture with the music. But that was that was my first impression about computer. It still feel as if it's a calculator. Like you it's a tool. If you put in something, it will show you something.
Yeah.
Right. But I think for now, the computer really changed. Do you think?
Yeah, so a computer is just a tool for automating tasks.
Mm-hmm.
So, you type in something, you get an image and some sound.
Yeah.
And so as we evolve, it's becoming easier to automate certain tasks.
Right.
Whether that's directly through programming or indirectly through AI.
Okay.
And so that's how I think of computers, is how to help automate this task. Because this
Mm-hmm.
project I was working on with a computer scientist my first year of grad school,
Mm-hmm.
we were collecting data, and we had a video that we needed to say when the actual action started and when it ended and how long they spent on a certain thing. And it used to be in psychology,
Mm-hmm.
you would do that by hand.
Right.
You'd watch the video,
Mm-hmm.
it'd take you however long,
Mm-hmm.
and then this computer scientist that I was working, he's like, I can write a little script that'll automate that, and you don't have to do it. The
Right.
computer will do it. And I was like,
Yeah.
oh, this is the power of computing. Is that all of this boring stuff that I don't want to do,
Mm-hmm.
a computer can do that if I can figure out how to tell the computer to do that.
Mm-hmm. So from that experience to where you are right now, so I know you've been conducting a lot of research, looking at what are the specific skill we need to teach children, what are the specific knowledge we should prepare teacher to know. But I think way before that, there's a critical issue that I really want to know your opinions on. Is why do you think introducing the knowledge about computing or computing skill to children. First of all, do you think that's important to introduce to children, or do you think it's better to introduce to children as early as possible?
I do think it's important because it's a way of thinking about how to interact with the world.
Okay.
So a computer is an incredibly powerful tool. Artificial intelligence is an incredibly powerful tool.
Mm-hmm.
And so the more that we can get students thinking of that as their part of their toolkit
Mm-hmm.
earlier, the better. And being able to think in a way that a computer thinks allows you to use that tool. And so that's why I'm really interested in teaching, especially young kids, how to use a computer, not just how to use an interface that they can only do this set of actions and get this specific output based on something that someone else designed.
Were you talking about the games, iPad games, kind of like that? Or okay.
Or even just a word processor or anything like that. If using an interface is not the same as computing, being able to create something where you're automating a task, you identify a task that you want to automate and you're able to create some sort of automation for that, that's way more powerful.
Oh, I see that's different is, instead of just simply being the user of a computer or using computing skill to do something, instead of just being simply a user, you're thinking about computing skill more like, oh, how can we all be creators, right? Or we are creating something new, a new program, new apps, or new practice of using that may help we develop as a social being basically, right? It's not only for personal growth but also for future professional growth. Okay.
So it's not up to just the people with computer scientist degrees to identify the problems that they want to solve, but everyone can identify problems that they want to solve and make that a possibility.
Okay. So where we are right now, so we know their kids already start playing iPads. There are tons of free programs or apps available for children to use, right? Is that what we're supposed to focus on when we introduce a computing skill to children? Just as for here you go, you play the apps, or what do you think?
Yeah, well, and especially at a really young age, I do think that playing games and using apps is appropriate, just because the skills that you need for computer science involve a fair amount of abstract thought, which just developmentally isn't appropriate at a pre-K level.
Right.
So getting comfortable using the computer in that way is really important, but you're not going to be able to really understand a lot of the concepts
Right.
that you would need to create a program at that stage.
Okay. So what like have you noticed there are any programs that you think, hey, this program, works for the kid the best?
So something I'm really excited about
Mhm.
is spatial games.
Spatial games.
So there's a lot of like programming activities that
Mhm.
I use air quotes to
Oh, yeah.
say programming activities because it's not really programming. It's like you're programming a mouse to go through a maze by saying like go forward 3 times, turn right, go forward 2 times. It's like, go forward and turn right are not programming concepts,
Mm.
but you're doing it in this sort of pseudo program language.
Mhm.
But it's also developing kids' spatial skills. And the reason that that is important is because spatial skills are correlated all across the board with STEM achievement of all times,
Interesting.
or of all kinds. And so, and that includes computer science.
Okay.
And like coming from a psychology background, I got really interested in this spatial component because like brain training, like tips to improve your memory or games to improve your memory or that sort of thing, they generally don't work. They don't transfer to other tasks very well, but spatial skills actually seem to. So there's like this, lots of meta-analyses that say if you train in spatial skills, you actually have better performance in your math, in your science, in your computer science class. And that's sort of bi-directional as well. So getting better at math and science also improves your spatial ability. And so for really young kids, the thing that I'm most excited about is having some sort of spatial game, especially in like a, pseudo programming context that lets them get comfortable with that sort of algorithmic process of move forward this number of times, but turn right, blah, blah, blah.
Okay.
But also helps them develop their spatial skill.
It sounds to me like when you say spatial skill and also like you follow some kind of orders or sequence to do this kind of action, it seems relies a lot on the logical thinking, right? And also it does require you to utilize some kind of like math thinking as well when you are interacting with the program also. What do you think about the connection between the language and such program? Because I know like computer program looks different. It's not the sentences, but they're like their vocabularies in it. How can we what are the components we need to introduce to young children about programming?
Yeah, and so the language aspect of it, I really see as helping define like the relationships between things.
Relationship.
So what I always tell people who are learning computer science is computer science is the new kid on the block. Like it was based on math, it was based on science, it was based on language. So if you know something about those, which everyone who's been in K through 12 education does, then you know something about computer science. And so that syntax in programming, we call it syntax, but it's sort of like grammar in language. It tells you what's the relationship between this piece and that piece. How do they go together? Like how do they interact with each other? And so that's where language really is important.
So for that, you think it probably is there some kind of sequence there? Like we probably want to make children to experience something first, and then special games, and then program. Is there any sequence like that, or?
Yeah, and so there's a couple of specific models in computer science, but in general, like from a pedagogical philosophy, I'm always a big fan of giving people concrete experiences before we try to teach them any sort of concept that underlies it. Just because if you can't even understand what you're talking about when I'm talking about some abstract concept, then you can't understand it. But if I give you an example and then explain how you might generalize that to others, then that's a good thing. But so there's 2 different models in computer science education. There's the use, modify, create model that says if you're learning to program, you should use a program, understand how it works, modify it, and then create it. And so most people jump straight to the create step, like they feel like they need to stare at a blank screen and write from scratch. And that's just as intimidating as staring at a blank page.
Because I learned it, like I think the very first thing we want kids to develop is this motivation and the interest, right? Like let's say if they just give me a Macintosh and just say program this with the DOS, I would not do it because it's so boring. It's just black screen, all of these letters and vocabulary I didn't recognize.
Yeah.
And even though they explain all the logic, to me, I will now feel interested in doing something with it.
Yeah.
Especially sometimes it can be really disappointing is when you do computer programming and you create some kind of bugs or errors. Sometimes you just have to, you just couldn't figure it out. Like it's really, challenging for you to figure out where it went wrong. And I think that's where some people quit. It's like, oh, that's it. I'm done with it. So having the opportunity for kids to really like experience it and use it first to develop this interest and feel comfortable using this tool, maybe will be a wonderful first stage. I think that's the same thing for teachers. Do you think?
Yeah. Yeah, to me it'd be the same as like you said, a kid at a piano and you're like, all right, start playing.
Yeah.
It's like they don't have any idea. Like they maybe have heard songs.
I think that's the problem. And sometimes it can be the same issue for teachers as well. Is we'll probably develop all set of the teaching standard of computer science, and then we just introduce it to teacher and say, here, those are wonderful standards. Go figure out how to teach it. But the problem is for many teachers, they haven't developed this experience of using the computer. Using the computer for their personal needs or using computer for their professional needs. And sometimes I often hear teachers complain like, oh, their school district, they start a new system. They're gonna spend 2 weeks to learn the new system. They don't want to learn that, And I feel like, hey, that doesn't sound right. If you have a system that your teachers feel difficult to use or don't want to use it, you cannot expect them to really do a good job using the system to do teaching, So I think that's a very good place where we have to do the perspective switching instead of just thinking about what we require teachers or require children to learn. We have to think about, have we already prepared them to learn, right? Prepare them to do something.
Well, that's why I feel like starting early is important, is it allows that perspective switching, that later on they're thinking of that as one way to solve problems.
Yes.
But this takes time. So it's interesting as I work with people over multiple years that I sort of work with them on a specific example that applies to them.
Yeah.
And then once they understand how that actually works, they start thinking of all the other things that they could apply this to. And maybe they don't have the technical skill to create the solution themselves yet, but they start thinking like, oh, I could fix this, or I could do that, or it sort of compounds on itself because it shifts your perspective.
Yeah. And then, I think it's a cumulative positive experience, right? Like once you start with a simple task and you're successful doing it, maybe at the very beginning you need somebody's support or you need to create your own team to work as a group, and gradually you realize, hey, independently I can also achieve it. That kind of cumulative positive experience really will get somebody to be more and more spontaneous and creative, right? In this problem solving and also using the computer in a positive way in the daily life.
Yeah, and that's why I'm so excited for artificial intelligence too. Is because now you basically have like your own team of people available to help you figure stuff out, especially like the debugging that you're talking about. Like you hit a bug, you're not sure how to fix it, you can spend hours and make no progress. But now you can go to your favorite artificial intelligence and say, hey, I'm having this trouble, this code is producing this error. And it says, oh, it looks like blah 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 blah, here's a way to fix it. And suddenly, like I did this for creating a graph in a paper lately. I was like, I would have spent an hour at minimum trying to figure this thing out. Instead, I put it into ChatGPT and said, hey, I'm having this problem, and it fixed it in 5 minutes.
Yeah. I mean, that's really a good use of AI, is to really help you to have a collaborator, have a helper to support you solving the problems. But are we already reached to the stage where we can like completely rely on AI to do all of the problem solving?
So AI is very good at tasks. It's not very good at jobs.
Okay, so that's the spoiler alert, and we're gonna continue our discussion on AI next episode. And stay tuned. We'll see you next time.